Welcome back to your chemistry class, children. Today we are going to discuss about our second chapter, that is acids, bases and salts. Acids, bases and salts. See, this is our second lesson, acids, bases and salts. See, you know very well, suppose if you are going to take lime juice, what's the taste would you feel while drinking lime juice? That is, without sugar we feel, what's the taste of that lime juice? You feel that is sour taste, isn't it? What taste you feel? That is a sour taste. So, do you think how will you get that sour taste from the lime juice? Suppose if you are taking orange or if most of the fruits, grapes, most of the fruits, if you will taste, it gives sour taste, isn't it? So how will you get that taste? Why you are getting that sour taste only from especially like these fruits? Do you think like this? Because these fruits, generally these fruits contains acids present in it. These fruits contain acids present in it. That's why we are getting this sour taste. See, generally not only these fruits and many substances which have sour taste is because of acids present in it. See, our stomach also secrete one acid for digestion. Do you know what's the name of that acid? That is, you know that HCl. What is that? Hydrochloric acid. So, our stomach also secrete hydrochloric acid for digestion purpose, isn't it? So like this, most of the substance that taste is sour taste because of the acids present in it. So about that acid, today we are going to discuss in this second chapter, that is acids, bases and salts. See, mainly in this lesson, first we are going to discuss about what are acids, and then what are bases, then what are salts, then what are the chemical properties of acids, physical properties of acid and physical properties of bases, chemical properties of bases and salts and their preparation. So everything we are going to discuss in this second chapter. So now we will discuss one by one. Listen. See, very first we are going to discuss about acids in this lesson. Do you know what are acids? Before this, you have to know about one word, that is indicator. Do you know this? What does mean by indicator? What is this? Indicator. See, mainly in cars, bikes, in vehicles, we will use this indicator. Why we are using that indicator? What's the purpose of this indicator in vehicle? That indicator will show whether if you are turning left or right, isn't it? So, in that purpose, we are using indicators in vehicles generally. So, with the help of this indicator, we will indicate other people's to whether you are turning left or right. Okay. Same like this, in chemical substance also, we will use some indicators to indicate the given substances acid, base. So, to know about that, we will use generally indicators. So, here we are going to use some indicators to identify whether the given substance is acid or base. So, first you have to know about indicators. What does mean by indicator? Indicator is a chemical substance. It is a chemical substance which indicate whether a given substance is acid or base. So, generally, indicator is a chemical substance. It will indicate whether the given substance is acid or base. By the help of indicators, we can identify the given substance whether it is acid or base. This indicator, we have natural indicator. See, we have natural indicator as well as synthetic indicator as well as olfactory indicator. So we have three types of indicators generally we are using. That is in this identification of acids and bases, generally we are using this natural indicator. We know what is meant by natural indicator means. Natural indicators mainly we will get from natural substance like plants and animals. For example, you know that is litmus. Litmus solution. Litmus is a natural indicator. This litmus generally we will get from the plants like lichens. Lichens, this is a plant of Calophyta family. We can spell this in the form of lichens also. So from this lichen plants we will get this litmus. So this litmus solution is a natural indicator. It is a purple colored dye. It is a purple dye. It is a purple dye. So the color of natural color of this litmus solution is purple dye. This is neither acidic nor basic. It is a neutral indicator. This litmus indicator is a neutral. It is neither acidic nor base. So this is an example, best example for natural indicator which we will use to indicate whether the given substance is acid or base. So how will you identify with the help of this litmus means? We know that we have different types of litmus paper in your laboratory already. We have learned from your 7th standard. That is, you have blue litmus and red litmus, isn't it? And with the help of blue litmus, if you dip this blue litmus in acid, that blue litmus changes into red color. If you dip the same blue litmus in base, there is no color change will you get. So we will get. So from this we can identify this indicator will change the color of the substance by using in acid and base. So with the help of color change, we can identify the given substance is either acid or base by using like these indicators. So this litmus is a natural indicator. It is obtained from lichens. That is, we will spell this lichen also. This is lichens and from Thalophyta family. And this litmus paper is naturally obtained from plants. So this is a natural indicator, and this color of this litmus solution is purple color, purple dye. And this litmus is a neither acidic nor basic. It is a neutral substance. So we will use this litmus in acid solution. We will get red color. We will use this in basic solution. We will get blue color. So this litmus we can use in the form of paper also, that is litmus paper also. We will use in the form of blue litmus as well as red litmus. Listen. See, what's the color change takes place when blue litmus in acid and red litmus in acid. Now we will discuss. See, do you know what's the color change takes place when this litmus, natural indicator, that is litmus in acid, blue litmus changes into a red color, and in base, red litmus to blue. So this is a natural indicator. This natural indicator shows color change in acids as well as bases. What's the color change will you get in acid as well as bases means that in acids, blue litmus paper, if we will dip inside the acid, it changes into red color. But the same blue litmus in base, there is no color change. Same like this, if you will take red litmus paper, that red litmus paper dipped into acid, there is no change. But in base, that red litmus paper changes into blue color. This indicates that by which help of color change, this indicator shows whether the given substance is acid or base. So this is natural indicator. Same as well as we have synthetic indicator, that is, what are the synthetic indicators mainly we will use in laboratory. What is meant by a synthetic indicator first? This synthetic indicators generally we will prepare in the laboratory, that is it is man-made indicator. We will prepare with the help of chemicals. For example, methyl orange, and phenolphthalein. Methyl orange and phenolphthalein. These are synthetic indicators generally we will use in our laboratory. That is, what's the natural color of methyl orange means? This methyl orange color is naturally, it is orange in color. What's the color of methyl orange? It is orange in color. So, what's the color change takes place when this methyl orange in acid and methyl orange in base. In acid, this methyl orange changes into a pink color. What's the color change will you get? This methyl orange in acid, it changes into pink color. In base, it changes into yellow color. What's the color change will you get? It changes into yellow color. Same like this, phenolphthalein. What's the color change will you get in phenolphthalein means? It is natural colorless. It is colorless. So, in acid also, it remains colorless. In base, it gives pink color. Generally, this pink we will get in the form of like red color. So, slight pink color we will get, but actually the color, it is look like red in color in methyl orange in acid, but this we will get that is dark pink color. So, methyl orange, the color of methyl orange is orange in color. In acid, this methyl orange changes into that is red color. In bases, the methyl orange changes into yellow color. Same like this phenolphthalein indicator is generally it is colorless. In acid, it remains colorless. There is no change in color, but base it changes into pink color. So it shows with the help of color change, with the help of these color change, we can identify the given substances acid or base. So these are synthetic indicators. These indicators are synthetic indicators. About this, we will discuss with the help of indicators we have in laboratory. We will discuss after school reopen. I will show to you how these indicators will work with acids and bases. I will show to you. Now just listen what's the color change takes place. So here this pink is not look like, we will not look like that is exact pink. We will get in the form of red color. So this methyl orange, it is generally orange in color. In acid it changes into red. In base it changes into yellow. Phenolphthalein, it is generally colorless. In acid it remains colorless. In base it shows into pink color. So with the help of these color changes, we can identify the given substances acid or base. Same like this, we have one more indicator. That indicator is olfactory indicator. What is this? Olfactory indicator. Olfactory indicators. So, first, natural indicators and synthetic indicators shows the color change when we will add it with acids or bases. But these indicators we will identify whether the given substance is acid or base by the help of odor. So by the help of odor only, that is smell. By the help of odor, that is smell, we can identify the given substances whether acid or base. That is, for example, if it is the children is visually able children, how they will identify with the help of these indicator means they can't identify, they can't see the color change. But they can identify with the help of smell change. These indicators are, that is olfactory indicators. It shows whether the given substance is acid or base by the change of odor. So, these indicators, for example, onion, vanilla, cloud. These are some examples of olfactory indicators. Suppose if we will take some onion peels or some onion, and we will tie that onion in one cloth overnight, and next day in that place if you will add acid or base, while adding acid there is no change in odor, that is by adding bases we will feel the odor change. We will not identify the onion smell. So by this way we can identify whether the given substance is acid or base. So with the help of smell, in acids we will get the same smell, but in base the smell we will not get that. By the help of this smell we can identify the given substance as acid or base. So these indicators are olfactory indicators. So what are the indicators we have discussed today? Indicators are chemical substance which shows whether the given substance is acid or base. The given substance is acid or base by color change and also with the help of odor. So by the color change we will use this natural indicator. It is obtained from plants and animals generally. And natural indicator we have discussed litmus. And some more natural indicators also we have, that is naturally occurred indicators. From home we can use the turmeric. It is also one of the natural indicator, and that is red cabbage leaves. Red cabbage leaves, turmeric, red cabbage leaves, and that beetroot also one of the natural indicator, and the essence of beetroot, and some plant leaves like hydrangea, petunia, and then hibiscus. These flowers also we can use this is an indicators. So these are some example of natural indicator, that is turmeric, red cabbage leaves, and hydrangea, petunia, and what is that, hibiscus. These beetroot, these are some examples for natural indicators. We can use this as an example of natural indicator. See, for example, if you are using turmeric in your hand, after washing with the help of soap, what happens? You will see the color change on that yellow color changes into that red color, because the soap is made up of what? It is base, isn't it? So like this, we will see the color change when using this turmeric, like red cabbage juice, like this. So these are some examples for natural indicators. And synthetic indicators we have discussed with the help of methyl orange and phenolphthalein. Methyl orange, generally the color is orange in color. In acid, this orange color changes into red color. What's the color change? Red color. And in base, it shows yellow color. And phenolphthalein is actually colorless. And in acid, it changes into, colorless, there is no change. But in base, it changes into pink color. So it shows this change in color in acid as well as bases. From this, we can identify these indicators are synthetic indicators, that is mainly obtained from chemical substance, that is in laboratory. Same like this, we have olfactory indicators. These indicators we will get from this. We will identify with the help of these indicators by the help of odor, not by the change in color. How will you identify these indicators with the help of odor? Means by using some onion or vanilla or clove. By using this vanilla essence, if you are using, or if you are taking onion, or if you are taking clove, we will get the smell of onion, we will get the smell of vanilla essence, and we will get the smell of clove gently, isn't it? Suppose if you are taking this onion, that onion juice, if you are adding in acids, we will feel the same onion smell. But in bases, the smell will not get detected. So with the help of this, we can identify whether the given substance is acid or base. So these indicators are used to identify whether the given substance is acid or base by the help of color change as well as odor change. Okay. So why we are going to discuss about this indicator means, because in this lesson, acids, bases and salts, these indicators shows important part in this lesson, because this only will helps to identify the given substances acid or base. By the help of these indicators, we will do activity based on this acids and bases using indicators. So we will do later. So now listen, these are the indicators which indicates whether the given substance is acid or base. So now we are going into the topic, that is acids, bases and salts. First we are going to discuss about acids. So today, very first I have intimated to you, if you are drinking on lemon juice, or if you are taking mainly fruits, if you are eating fruits, mainly we will get the smell of, that is what is that, pleasant smell, and if we will taste means we will get generally sour taste, isn't it? The sour taste is based on mainly why we are getting the taste in many fruits and in lemon juice and in some other juices, means because that contain acids present in it. Due to that reason only we are getting the sour taste, because acids, we will call it as an acidus. The meaning of acid is acidus, that means sour in taste. So based on this only we are calling this, generally acids contain sour taste. Because of this reason, why? Because acids are contain this sour taste means because acids generally present in these fruits and that is citrus fruit. Generally all the citrus fruits contain sour taste, because all the citrus fruits contain acids present in it. So this sour taste is because of acids present in that fruits and vegetable. So we are calling these are acids. Okay. See, generally acids also we have different acids. So how will you differentiate acids? Means we have strong acid, we have weak acid, we are calling organic acid, we are calling inorganic acid, and concentrated acid and diluted acid. So how we are telling that is these type of acids means it is based on the where we are getting, based on the sources, based on the concentration, based on the ionization. We can classify acids into different types. Okay, now we will discuss one by one. Listen. Listen children. See, generally what's the taste of acid? Sour taste. And these acids generally based on this sources, based on sources, these acids can be classified into, based on sources, these acids can be classified into organic acids and inorganic acids. Listen, based on sources, acids can be classified into organic acid as well as inorganic acid. See, what does organic acid means? Mainly these organic acids obtained from plants and animals. These inorganic acids are otherwise called mineral acids. Mainly we will get from rocks and minerals. Listen, see, generally organic acids obtained from plants and animals. These inorganic acids are otherwise called mineral acid because these are obtained from rocks and minerals. So, based on their sources, acids can be generally classified into organic acid as well as inorganic acids. See, for example, we can say example for organic acids, that is formic acid, acetic acid. This is formic acid. This is acetic acid. Formic acid. This is acetic acid. See, listen. Which acid? That is formula of formic acid. This is HCOOH, and formula of acetic acid is CH3COOH. About this, we will discuss in your what's that fourth lesson, carbon and its compounds. How we'll write that formula of formic acid as well as formula of acetic acid about that. Now don't worry about that. Just you have to know that is formic acid, acetic acid, same like this. Malic acid, citric acid, tartaric acid, then lactic acid. So like this we have some examples of organic acid. Generally curd contains lactic acid and apple contains malic acid, and citrus fruits like what is that, lemon and orange contain citric acid, and grapes, tamarind, these contain tartaric acid. So like this, and same like this, tomato. In tomato we have oxalic acid. So oxalic acid present in tomato. So like this we have some examples for organic acid. Generally organic acid obtained from plants and animals. Same like this, do you know ant? Ant has what acid present in it? It is formic acid present in it. See, suppose if ant sting generally indicate formic acid. We are getting pain when ant sting, we will get pain generally, isn't it? That pain, why happens that pain and irritation means because that ant sting will inject formic acid. This formic acid is otherwise called methanoic acid. What's the other name of this formic acid? That is methanoic acid. Chemically, the IUPAC, that is another name of this formic acid is methanoic acid. So generally ant has this formic acid or methanoic acid. So ant inject this acid, because of this reason only we are getting that pain and irritation. Okay, so organic acids are obtained from plants and animals generally. For example, formic acid, acetic acid, lactic acid, malic acid, citric acid, tartaric acid, oxalic acid. These are some examples for organic acids. And generally, curd contains lactic acid, and apple has malic acid, and lemon, orange like the citrus fruits has citric acid, and grapes, tamarind, this has that is tartaric acid, and tomato that is oxalic acid present in tomato. So these are some examples of organic acid. Same like this, next we are going to discuss about inorganic acid. So inorganic acids are generally we are getting from rocks and minerals. So these are generally we are getting from rocks and minerals, and also synthesized in laboratory. So we are calling these mineral acids or inorganic acid. So these inorganic acid, I will give you some example. That is, listen. Inorganic acid, I will give you some example. See, HCl. What is this? Hydrochloric acid. Hydrochloric acid. And H2SO4. What is this? This is sulfuric acid. This is sulfuric acid. And then HNO3. This is nitric acid. This is nitric acid. Okay, and same like this. See, H2CO3. This is carbonic acid. Carbonic acid, as well as H3. H3PO4, that is, this is phosphoric acid. See, listen here. See, inorganic acid generally obtained from minerals, that is rocks and rocks. synthesized in laboratory. So HCl, this is hydrochloric acid. Formula of hydrochloric acid is HCl. And H2SO4 it is sulfuric acid. And HNO3 it is nitric acid. And H2CO3 it is carbonic acid. And H3PO4 it is phosphoric acid. So these are some examples of inorganic acid or mineral acids. So generally, listen here, these organic acid and inorganic acid, generally what is common in this acid means, listen, all acids contain hydrogen ion concentration. See here. See in this all acid, what is there in this acid? It has hydrogen ions. Here also it has hydrogen ions. Here also hydrogen ions. Here also we have hydrogen ions. How will you separate this HCl means? It will separate in the form of H plus and Cl minus. So you know very well what is positive ion and negative ion. We have learnt in your 9th standard. That is cation and anion. If we will dissolve this hydrochloric acid in water, it will separate it into positive ion and negative ion. Isn't it? So how it will separate into positive and negative ion means, because these contain positive as well as negative ions, easily ionized to produce positive ions as well as negative ions, that is cation as well as anion. So all acids generally contain what means, it is hydrogen ions. So generally acids, the taste of acid is sour taste, and acids contain hydrogen ion concentration. Acids contain hydrogen ion concentration. Same like this, when generally acids dissolved in water, it produces hydrogen ion concentration or hydronium ions. When these acids dissolved in water, generally acids dissolved in water to produce H plus ions, that is hydrogen ions and H3O plus ions. This is hydronium ions. What is this? Hydronium ions. That means in water, this H plus ions converted to form hydronium ions. So generally when we are adding acid in water, what happens? Acid contains hydrogen ion concentration. When combines with water to form hydronium ion, as well as generally acids dissolve in water to produce hydrogen ions or hydronium ions. So the physical nature we will discuss about acid means, acid generally has a sour taste, and these acids has hydrogen ion concentration or hydronium ion concentration when dissolved in water, and this acid change blue litmus to red. Acid change blue litmus to red. These are the physical properties of acid generally. Acids, what's the color of acid? It is colorless. Generally acids are colorless and has sour taste, and acids produce hydrogen ions or hydronium ions when dissolved in water. Then acids change blue litmus into red litmus when litmus is dipped in it. So these are physical properties of acids. So what we have discussed in this, we have discussed about what is acid. Acid is the name of acid is derived from this acidus, which means sour in taste, and these acids are generally colorless, and acids produce hydrogen ions or hydronium ions when dissolved in water, and this acids generally change blue litmus into red litmus. So these are the physical nature, that is physical properties, physical nature of acids. Next we are going to discuss about, that is some more types of acids. That is, now we have discussed organic acid and inorganic acid. What is organic acid? It is derived from based on sources. Acids can be classified into organic and inorganic. Mainly derived from plants and animals means it is called organic acid. From minerals, that is rocks and minerals, means it is inorganic acid, isn't it? And based on concentration, acids can be classified into, what is that? Strong acid as well as weak acid. Based on, listen, based on concentration and based on ionization. Based on, first we will discuss about based on ionization. Acids can be that is completely ionized in water is called strong acid. This is weak acids are partially ionized in water. What is meant by completely ionized? What is meant by partially ionized? See, now we are going to discuss. See here. Strong acids based on ionization, acids can be classified into strong acid as well as a weak acid. So, which acids are called strong acid means the acid which ionize completely in water are called strong acid. For example, this hydrochloric acid in water, it completely ionized to form H plus and Cl minus. Same like this sulfuric acid in water completely ionized to form H plus and SO4 2 minus. Same like this nitric acid in water, it completely ionized to form H plus and NO3 minus. So like this, the acid which completely ionized in water are called strong acid. For example, hydrochloric acid, sulfuric acid, nitric acid, these acids are called strong acid. Same like this, what are weak acids means? Listen, what are weak acids means? The acids which partially ionized in water. What is meant by partial? It will not completely ionized in water. Only partial. Some amount of hydrogen ions only it is completely ionized in water. That is called weak acid. For example, see acetic acid. What is this? This is acetic acid. So, this acetic acid, what's the formula? Says 3COOH. See, this acetic acid contains how many hydrogen ions? Here 3 hydrogen, here 1 hydrogen. Totally 4 hydrogen ions. But when dissolved in water, this is separated into CH3COO minus and H plus. This indicates that only the partial ionization only takes place. See, here also we have 3 hydrogen, but not these 3 hydrogen ions are separated. Only few hydrogen ions only it is separated. So this indicates that these acids only partially ionized in water. So we are calling these acids as weak acid. So based on ionization, these acids can be classified into strong acid as well as weak acid. Which acids are strong acid? Acids which come strong acid. For example, we can say that hydrochloric acid, sulfuric acid, nitric acid. These acids are completely ionized in water. So we can say these are strong acid. And what are the acids we can call it as a weak acid? Whether formic acid, acetic acid. So formic acid also generally contain, that is HCOOH. Here also only, what's that? Partially ionized. The ions are partially ionized in water. So formic acid, acetic acid, and most of the organic acids are weak acids. So based on ionization, acids can be classified into strong acid as well as weak acid. Next, we are going to discuss about based on concentration. Based on concentration, acids can be classified into, that is, concentrated acid and dilute acid. Listen, based on concentration, acids can be divided into concentrated acid and dilute acid. See, what is meant by concentration and dilution? See, based on concentration, that means when acids dissolves in water, the amount of acid is maximum and water is minimum, means that acids are called concentrated acid, and in water the amount of water is maximum and acid is minimum, means it is called diluted acid. For example, if we are taking any acid, if we are mixing that acid in water, only very that acid amount of water is very less amount, that is only minimum amount of water is mixed in acid is considered as an concentrated acid. Okay, so amount of acid is maximum. In acid, it is called concentrated acid. In acidic solution, amount of water is maximum is called concentrated acid. In acidic solution, the amount of water is minimum is called dilute acid. Is it right? No. Listen children, listen carefully. Concentrated acid. What is concentrated acid means? That is acid is maximum. In dilute acid, acid is minimum. Listen, what is meant by concentrated acid? In acidic solution, the acidic medium in the acidic solution, acid amount of acid is maximum. That is maximum amount of acid in acidic solution is considered as a concentrated acid. Only very small amount of water only added to mix that solution, that is to prepare that solution is called concentrated acid. And in acid, amount of acid is minimum and water it is added more means it is considered as a dilute acid. That is concentrated and dilute is based on concentration. So acids can be classified into organic acid as well as inorganic acid based on sources, and it can be classified into strong and weak acid based on ionization, and based on concentration it can be classified into concentrated acid as well as dilute acid. So in acid, just you have to know about one word in acid. That means mainly we will call it as an basicity. This word generally we will use in acid. That is basicity means it is nothing. The number of replaceable hydrogen ions present in acid is called basicity. Number of replaceable hydrogen ions. Number of replaceable hydrogen ions present in acid is considered as an basicity of that acid. For example, listen, in HCl or in nitric acid, see how many hydrogen ions are present? One hydrogen ion. So how it will separate? H plus NO3 minus H plus Cl minus. So the number of replaceable hydrogen ions here it is 1. So these are monobasic acids. Generally these acids we will call it as a monobasic acid. Same like this. See H2SO4. In sulfuric acid, hydrogen ions, it is 2 hydrogen ions will separate. So it is 2 hydrogen ions will separate. So number of replaceable hydrogen ions is 2. So this is dibasic acid. Same like this, H3PO4 in phosphoric acid, number of replaceable hydrogen ions is 3. So this is example for tribasic acid. See, now I will ask one question to you, whether acetic acid, totally it has 3 plus 1, 4 hydrogen ions, isn't it? But the number of replaceable hydrogen ion, that is CH3, COO minus and H plus. So the number of replaceable hydrogen ion is only 1. So this is example for monobasic acid. So only it contains 1 hydrogen ion, also it is monobasic, but it contains acetic acid contains 4 hydrogen. But why we are calling it as a monobasic acid means because what is meant by basicity? The number of replaceable hydrogen ions present in acid is considered as a basicity. So number of replaceable hydrogen ions in hydrochloric acid and nitric acid is 1. So we are calling monobasic acid. In sulfuric acid it is 2. So we are calling dibasic. In phosphoric acid it is 3. So we are calling tribasic. Same way, but in acetic acid it has 4 hydrogen actually. But the number of replaceable hydrogen during reaction is only 1. So this is example for monobasic acid only. Okay, just these things you have to keep it in your mind. So Sometimes they won't ask in your examination, but you have to know what is this. Suppose they will ask what is basicity. You have to know this word. Mainly we will use an acid. That is number of replaceable hydrogen ions present in acid is called basicity. That means only one replaceable hydrogen, we can say this is monobasic acid. Whether it is 2, we can say this is dibasic. Whether it is 3, we can say it is tribasic, and so on. Okay. So today we have discussed about acids, bases and salts. That is our second chapter, children. In this we have discussed about very first indicators. So indicators, generally it is used to identify whether the given substance is acid or base by the change of color and by the change of odor with the help of olfactory indicator. So these indicators generally we will prepare in laboratory. Some indicators we will get from natural substance. So these indicators we have different types like natural indicator, olfactory indicator and synthetic indicator. So all these indicators shows whether the given substance is acid or base by the change in color or by the change of odor. So with the help of this, very first we have discussed about acids in this lesson. Acid, which means that is acidus, that means sour in taste. So why most of the fruits and vegetables are sour in taste means because they contain acids present in it. So this taste of acid is a sour taste, and color of acid is generally colorless, and these acids change blue litmus into red litmus paper. But red litmus, there is no change in acid. And what's the color change takes place by using indicators means we have discussed with the help of naphthalene as well as with the help of methyl orange, and same like this litmus solution. So litmus solution is neither acidic nor base, it is a neutral. And these acids based on sources can be classified into organic acid as well as inorganic acid. Organic acid mainly obtained from plants and animals. Inorganic acid obtained from rocks and minerals. Same like this, based on ionization, acids can be classified into strong and weak acids. What are strong acid? They are completely ionized in water. What are weak acid? Partially ionized in water. Same way, based on concentration, acids can be classified into concentrated acid and dilute acid. So today we have discussed about acid, and in our next class we will discuss about what is bases and the chemical properties of acids and bases. Thank you, children.